Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. I'm joined as usual by Nik, founder of Postgres AI. Hey Nik.
Hi Michael.
And we also have Radim Marek with us, who is a consultant and Postgres enthusiast, whose boringSQL site we have mentioned many times on the show. Welcome, Radim.
Hello guys, thank you for having me.
Thank you for coming.
Yeah, absolutely. So we wanted to talk about a newish project you have kicked off called RegreSQL, about regression testing SQL queries or SQL queries. Very cool. It got quite a lot of uptick on Hacker News, a lively discussion on there. Congrats. But also, I'd be interested in discussing with you about how you got into the topic, like regression testing in general. Where would you like to start?
Okay, so that's the tough topic to start with. So effectively, it wasn't my project, or it didn't start it as my project. It actually has started as a complementary project to a book called The Art of Postgres, which I still believe is one of the best things you can do to learn how to work with Postgres.
Dimitri, right?
Yes, Dimitri. And I'm trying to get in touch with him forever, like last 4 years, but I'm not able. So maybe if he hears this podcast, that I will have a chance to talk to him. So I did start with the project because I was kind of a bit worried about how people deal with the SQL queries in their code. Because usually it's either generated by ORM and you don't see it, or it was a string hard-coded in my case, Go files. So you can see it in TypeScript files. And all the testing around this one originally kind of bothered me, because you have a infrastructure which was difficult to start, set up, and everything. And I said there must be a simple way. Something that actually running a simple query doesn't take minutes or seconds to do all the infrastructure tier up, tier down. And I found RegreSQL that is doing this job. And I tried to fix the project. And fast forward, I think 4 years, because it's actually quite a long time ago. I found another use cases because I'm working on some educational products and I needed to test whatever users are hitting the metrics that I'm interested in. And then I kind of figure out, yes, this is actually where it can come in, because it was comparing whatever the output, the correctness of the query. And that was only a step away, because then I realized, okay, every single incident is based on increased time on SQL queries. And that was just a small step to go from something that is predictable, because time is unpredictable. I got into something predictable, and this is where I started. So I start committing, I start adjusting it. And right now I'm actually working on a version 2.0, which is a big update in terms of functionality and in terms of developer experience.
But how do you approach the testing? So I understand the tool. It's for regression testing. It's super important these days, especially because there are no more excuses not to have 100% coverage of tests and proper coverage, not just like good-looking coverage. But, and performance testing in CI, and even before your AI assistant commits and pushes code, that should happen before probably. How do you approach the fact that we need a lot of data to have proper plans?
Okay, so this is effectively never-ending topic, how even developers can get to something which is representative of their database. I actually call this one, I think that happened somewhere on Hacker News with somebody from Supabase. We came up to a topic which was called It Works on My Database. That's the same issue. But to answer your question is, as I said, initially I naively thought I can do a time, but time is all over the place and that wasn't working. So the only way how to approach this one is buffers and cost.
Let's pause here because I think it's super important. I think industry doesn't understand it yet. We chatted about buffers with Michael 2 years. Finally, Postgres 18 has it by default in explain and analyze. This is great, like absolutely great. So industry doesn't realize how important it is to shift focus from timing to buffers still, right? Why timing is not enough? Why is it not so good when you control performance? What's your point of view on this?
Okay, so timing, Timing is a perfect metric because this is what you see if you come in the middle of incident. Timing is actually the easiest to spot metric. Queries are timing out. Hopefully all of us have, statement timeouts, transaction timeouts, everything in place.
And humans need good timing. This is our final goal, right?
Exactly. But the problem is, if you want something fast, explain alone doesn't give you timing because that's just, what the planner thinks. And explain analyze can't give you something that is predictable. So if you want to do a regression testing, you can't rely if you are running on, I don't know, underutilized AMD machine or ARM machine, or you're running on your exactly. Or everybody these days, we have Apple Silicon Macs and they are super fast. Their I/O is fast. So timing is generally
doesn't work in CI.
It doesn't. Yes. Well, it doesn't even work in production because you will get a big spread of queries. You still have outliers. One customer can hit 10,000 rows. One customer hits 5 rows. How do you
locking, wait on locking acquisition as well. That's
exactly.
That's great. Yeah.
I think it's even worse in CI. I think it's even worse in CI because flaky tests are a nightmare. So even if, for example, we accepted double the time, if we said fail this test if it's double the time, and that worked 99% of runs, when it fails, but for a bad reason, when it fails, it's picked the same plan, no indexing changes, nothing has actually changed, but there was just something else happening on the machine at that moment, and it kind of blitzed past its P99. We got that one time it was slow, and the test fails. That's now a flaky test. That's a test that sometimes fails when it shouldn't, like false spot. And those are always the nightmare tests.
Before we proceed to the solution, we all agree, buffers, right? Still, let's pause maybe. I have a crazy idea. I'm thinking for several years about this. Maybe it's time to implement it. Probably it's better topic for our hacking sessions with Kirk and Andrei we have usually on Wednesdays live. But your opinion, I'm very interested to hearing your opinion. What if we still keep analyzing timing, but imagine, wait events, right? Which usually are used in aggregated form, like how many active sessions, aggregate, and so on. What if that analysis would be brought to explain and analyze, to understand how this timing was spent exactly? Was it heavyweight lock acquisition waiting, or I/O was too slow this time? If in this case, wouldn't it help to extract to structure the whole latency to split it to pieces, and in CI context, extract pieces which are unpredictable? Okay, this doesn't matter. Okay, waiting time, it doesn't matter. Waiting on lock acquisition, but here we see a lot of actual CPU non-waiting, which usually is null, right? But there is trick there. But anyway, wouldn't it help to keep still keep timing as main metric for regression testing in CI for performance?
I believe in theory that would work, but for me the complexity behind this is already implemented on the cost and buffer level. So I'm not sure if the benefit would actually be having better metrics, because what I found out is, and we can get to the discussion, is buffers are fixed. If you have a predictable data set that you start with and you have a ideal state scenario, I think that's the important ideal state, because production is never in ideal state. You will have a bloat, you will have my regression testing is
always
never going
changing.
to match a
Also
exactly everything is changing, so it depends. But if you want to do a regression testing, you just need a metrics, one or two of them, which are predictable. Buffers are always predictable.
Yeah, I'm so interesting because you came and talk what I was shouting on every event basically. Buffers. I even have T-shirt with explain less buffers where buffers is bold.
By the way, it can depend a little bit, unfortunately. It depends what you mean by buffers, but if you include planning buffers, which are sometimes reported, there are states that, for example, whether if for example auto vacuum just ran, you might end up with if analyzers just run, you might end up with a different number of planning buffers than if it hasn't just run or if it hasn't run recently. So there are slight variations. So yeah, it might not be perfect, but cost is an interesting one. for sure.
So, okay, what I'm going to do, I will postpone my comments about why not only buffers, and maybe let's return to timing, and we will discuss maybe later. But I agree with you. Like buffers is the thing that doesn't depend on the state so much. So we just check hits and reads of shared buffers, also temporary, like everything. It's I/O. Database is all about I/O, right? But still, the question remains how, like your approach, like you need a lot of data to reproduce the executor behavior, so you will see proper number of buffers, right? You cannot do it with database sizes smaller.
Yes, that's the part. It works on my database because developers, they will start with hundreds. Cardinality of the data is going to be very small. And I haven't seen a single company that wouldn't have a problem with how to get a kind of representative set of data to developers' machines. Well, I know there are attempts, but like if you take an average software team, they usually have huge issues on this one. So my issue, and that's actually part reaction to Michael's comment, is I do always have to start with a clean slate. So for me, this is not a production, so I have to count that vacuum run and statistics are up to date. Mm-hmm. The original solution, which I described, fixtures, they are the obvious solution. So, I will always have to improve the ways how to improve the fixtures. But the way how to do it, and this is actually my roadmap towards version 2.0, is to do a snapshot building. You probably seen, well, you actually seen because you have discussed it, that instant database clones. That article wasn't a coincidence. It was actually for me need how to get a fast start state for the regression testing, and I needed something that works. This is why I had to dig, and then I actually, same as you guys, I was surprised it's already there, because it wasn't something I was aware actually exists in version 18, but suddenly everything was done. So it's not for production use, which you mentioned correctly, because there are still issues. But if you fix a easy to get starting point, if you imagine you have a predictable build, which actually is coming, it's now already committed, but it's coming for version 2.0 as part of the developer experience, and you have a fresh statistics, you can run the query. And if your configuration, Postgres configuration is actually a very interesting part because you can change the cost, how it's calculated, but you will always get the same buffers.
Exactly. If you talk about hits plus reads, probably the distribution will be different. Also, hits might be hitting the same buffer multiple times, so there are nuances there.
But the total,
it's like a
total is always the same.
Yeah.
So. And Nik, you said it. All of us came from a spindle disk. So you remember times where you tried to hit the Control-C on the query and, it was just flushing wall files on the disk. And we can say that I/O is cheap these days, but it's not. It's still the only metric that you have to do. And I/O, whatever there's a contention, will affect time.
Yeah.
So for me, suddenly buffers is number one. So there is nothing more predictable. Cost is very close, and I actually I haven't done like a scientific research on the topic, but if you take the one version of Postgres and you run through different architectures and same settings, the variance is surprisingly low.
Not all settings. There is a specific set of settings because you can have much less memory, shared buffers can be very small, you just need to set proper effective cache size, all the planner settings and work mem. We have an article about it. And then, I agree with you, it will be the same planner behavior for the same version. That's it. It's great. It's magic. You can have Raspberry Pi and repeat behavior of huge, like 800 core machine. It's insane.
Exactly. This is what I did. I actually took my old Raspberry Pi. I took Hetzner ARM machine. I took a GCP machine. And the difference was something around 2%. So right now I have a threshold of 10%. By default, but I'm looking forward to actually make it configurable.
That's great.
And let's people decide. But and then the answer to all your initial questions is I don't have to care about timing because in production, if you would have 1,000 transactions per second, I/O will get saturated, and that will naturally raise the timing. So if you care about buffers, you don't have to care about timing, because timing is just, extrapolation of problems that happened before actually the query returns.
Some people say, like, let's do proper full-fledged benchmarking and just to study behavior of planner for a few queries. It's wrong idea because you have so many moving parts around. Like, you just narrow down to single plan, single session, right? And focus on what matters, I/O. But here, like I had that question. So you mentioned create database in Postgres 18, you mean strategy, right? When you can copy and write clone, and when you have create database with clones template one database, but not in regular form, but basically very fast because of copy and write. Does it mean you use ZFS or something, B3FS or what?
Well, it depends what you want. I'm not forcing people to use anything. I'm just offering an option if you want fast. Because, another part of frustration was that everything in your integration test that touches the database is slow.
Mm-hmm.
Yeah.
And the way how people normally use it, it's slow. But, running most of the queries is like literally milliseconds.
Yeah. And we have Neon branching, we have other copy and write branching, so that's great. And here, if you compare, like, do you know about DBLab or no?
Yes, I know.
Yeah, so I'm comparing the various approaches, and this approach, when we have multiple logical databases in physical, is great because this is exactly what we try to achieve with DBLab, but not many people realize what you just said. I hope with this maybe episode more people will realize. And the thing is that if you allocate this machine, you can have huge database. This wonderful Postgres 18 feature, if you use ZFS, we don't care about time anymore, right? Almost, right? So we focus on buffers. Postgres doesn't know which file system we have, right? And then you can achieve constant price for many tests in parallel. Unlike Neon or Aurora thing cloning, you need to pay. If you run 10 tests in parallel, for example, you can have 10 ideas from LLM, you need to pay 10 times more for compute. Yes, storage solved, but compute is not. Here, create database, 10 databases in parallel, it's great. The only thing compared to DBLab, what is not possible, you cannot upgrade, you cannot have a major upgrade inside a clone and have independent versions in parallel, But maybe some more differences, but in general, it's great that it come to Postgres naturally. This feature, it's a great feature. I hope it will get traction in CI environments.
I think it's actually great to have this natively. I'm not saying it's a perfect. It's just an option. Nobody is forced into a third-party solutions. Everybody will pick whatever they want. And, I'm not against Neon or anything. I think you evaluate your requirements and you say what's the best approach you want to take.
Well, with Neon, it's also the same. Like but you just pay for compute, but also you can study planning behavior, put it into CI, and the thing is that you need to focus on buffers because cold startup will be different, right? But we don't care anymore if we focus on buffers. That's a magic, right? That's great, and cost, because this is what says how planner thinks. The only problem is there are some queries which are out of this methodology. For example, when people who deal with RLS, they know this problem, right? If you have a query with counting million rows and there is a hidden filter involving current setting, it's going to be executed for each row. And it's not buffers. It's pure CPU time. But these are exclusions, right? We have only limited number of them, right?
Exactly. I would say before hitting that problem, there is 99% of problem we can solve it much easier.
I agree. It's and still you can troubleshoot it on this machine because getting those million rows is much faster if you have this copy on write and your methodology. I mean, what you said, it doesn't mean you should stop thinking about timing, right? You still can think about timing, right?
You can. It will hit you. That's what's going to hit you in production at the end of the day. Because this is what the user perceives when they render the page, waiting for the output or something. Yeah. But it's not predictable.
Yeah,
easily
the problem is we gave this tool, DBLab, to many hundreds of engineers and noticed, I think thousands already, and noticed that some people expect that it's full reproduction of production behavior. They say, why my index is being created 3 times longer than in production? Well, because quite different environment, right? So there is some adjustment needed in mindset to test like this, right? Well, okay, enough about cloning and branching. Let's think about tooling. Yeah.
I had a question going back to cost tolerance. You mentioned allowing for 10% higher costs, and that confused me slightly because I was thinking on CI we'd always be running on the same date, or effectively a clone of the same database, static state you mentioned. Why would we need to allow for 10% higher costs potentially?
That was initially my naive protection, effectively. So before I did the benchmarking, I said, 10%. Literally, there was no measuring. I just said 10% sounds reasonable. When I did measuring, I found, as we discussed, there is slight variance, but it's not actually, I think on average was below 2%.
I would like to see details here because I think there should be zero difference if we
Same.
let's talk. I'm going to follow up with you on this because if there are some cases which I don't know, I'm super interested to understand. And yeah,
I will just just to finish the topic because I did extensive testing in terms of establishing it. I haven't dig into a reason because some were ARM machines, some were very Raspberry Pis, so that wasn't comparable, and that was where the difference came from. Some queries were zero.
But Planner doesn't know about hardware. Doesn't know anything about hardware.
We actually had this discussion on the Prague Postgres meetup 2 months ago, that it would be actually very interesting to go into a differences between ARM and Intel processors. What actually is, if there is some default somewhere. I have, for example, seen that I/O startup time, again, it doesn't involve buffers, but the I/O startup times on the cold I/O are much slower on ARM in general.
Because
I
it might be
believe that
different
there might be
code,
something else.
different code paths.
Exactly.
Right. This I can imagine. Yeah, but it's not about hardware, just code paths. The architecture might matter. Yeah, that's interesting. Yeah. What's also interesting here, I think we touched interesting topic. Could zoom in there. It's because it's super interesting. When we say 10%, I think it's because in CI you need to define some thresholds to define when it's failed, when it's passed, right? And it's when you work manually, you have some like thresholds in your mind you don't realize, but then you need to code it basically, and this is a challenge, right?
Exactly. This is where it started from, and this is actually where I hit a wall with the original release of the tool, because people didn't understand. You said it. People didn't understand buffers, why they matter so much. People didn't understand why something is changing, and I had to start thinking again. And this is, I think if you would go to original blog post, now there is a notice that I had to take the fixtures out of the test because people were kind of linking it together and they were getting different data sets and they didn't use it correctly. My fault was that I didn't specify it properly. That was the issue with the blog post. But this is why the version 2.0 is actually heading in the direction, because we have touched on the topic. You can have multiple snapshots, and those snapshots will give you a different experience. But the same baseline on a given snapshot should be stable or more or less stable over time. And then it depends, because your business will change, business requirements will change. Then, for example, yesterday I committed a change, which is a selective update. So you can literally link a change in baseline to a commit. So you can say and blame what actually was that kind of historical trend change on a query. So this kind of adds another dimension, because suddenly you don't have a git blame only who broke something. You actually can trace it back to how did it affect the performance. And this was actually on one of the posts, Michael, you had on your blog about this optimization from 7 milliseconds to something. You hit the index scan, and that was actually a big inspiration, because I said, this is actually very important, because the reason that query does 7 milliseconds, that doesn't matter. But if you save so many buffers, you should be able to trace it back even on the positive outcome. So at one point there can be a layer which will take all those optimizations. And this is where we will get to very interesting topic, and that's the topic, and that's AI.
Right. Experiments, right?
Well, I wouldn't call it experiments. I call it set reality, because I believe
You
Most
mean
people.
code is written by AI only right now, right? Most
Yes.
code. Yeah. And how do we control it, right? So as I said, we need not only 100% coverage by age, but it should be real tests should be inside, right? So including performance. I agree. Yeah.
So yeah, we had a discussion with Michael in London during a PG day. If you have a context which AI don't have at one point, you can then see RegreSQL actually in a very different light because it knows the query, it knows the baseline, it has a snapshot, and it has a context, which is the schema.
Exactly. And statistics.
Exactly, you have statistics. So you have suddenly much more data which you need.
Yes.
And I had to, all of us have to think about how AI is going to change our
I'm thinking
work.
every day since 2017.
Exactly. I have a weekly session which I do, and I'm trying to digest the news and do this one. But there are things that just confirm that this is the right direction, because the joke is 84% of developers use some sort of assisted coding, or they wipe code or whatever. We all do it.
Yes.
But the same 84% of people, they don't write SQL queries anymore.
Yes.
If they were bad in writing SQL queries, you know how LLM SQL queries look without the context. I actually found it, this is the deformation you have when you look into how Planner works. I found it very funny because it doesn't differentiate whatever you run in Postgres 12, 14, 18. It will mix all that advice. It kind of reads the blog post, which suggests you something wrong, and people will just go with it. And if you put this one in context of a 10 times more pull request, who's going to review it? And now you see where all this coming through, because if you don't have time to review it, if you don't have the human aspect of reviewing it, and if you don't have the DBA knowledge, I think the lost DBA knowledge is actually kind of key here. You need something that will govern that your tests are fine. You can write unit test, integration test on a couple of rows, but how do you do it if you have to return 5,000 rows? This is very difficult. And this is what RegreSQL actually was doing ever since start. You can take a 5,000 rows and compare them. And it can suggest order is wrong, or maybe, there is a wrong field, and it will notice it. So actually that comes about, somewhere between unit test and integration test. It can measure or control that your data and your contract is still valid. And this is where I believe the direction of the tool is actually having a big future.
That's absolutely great. I just everything you say makes total sense, absolute sense. Yeah. That's great that we think in the same direction. That's all I can say.
Well, thank you. But I would say, this is, if you have experience dealing with production system, this is what you will effectively arrive to.
Yeah.
Because you have to generalize, you have to find
Guardrails.
underlying issues.
We need guardrails
Exactly.
and protection, automated protection at a larger scale. We cannot say, oh, let's prepare to run those pipelines, right? Because they are expensive and long. We need making them cheap and fast, radically, right? So we can run 50 of them, right? And check all the things and throw away all hallucinated stuff, right? This is the way, yeah. This is the way. And then it comes to many details, including, for example, there are some hard problems which come from production side, not from development side. For example, plan flips. And plan is different. But it's a different problem. If you split these problems, anyway, I agree the most danger to performance right now is AI. But it's also great. But it's wild west right now, right? So we need some practices and tools to be established.
But just to kind of put it in contrast, I actually believe most issues are actually very simple, because most incidents, they start, I'm not sure if I'm the only one, but most incidents you see are literally simple, missing index. Mm-hmm. Or somebody rewrites index without understanding how it should be rewritten. And, they obviously verify it locally. It works fine because they have a small database, but they don't notice that the query exploded 100 times in terms of buffers retrieved, and that will have an impact. Well, 100 times is easy. That usually you can survive it.
Important point here also, I noticed, if you say 1,000 buffers, people don't understand you. If you say 8 megabytes, they start understanding how much it is, right? So you just multiply by block size, and this is magic. so simple magic, you know.
It is. That's and this is. I don't want to sound as a promotion. I'm building it's called labs, so we both have labs of some sort.
It's for experimentation. It's right, yeah.
Because for me, and you mentioned it, Nick, before, developers want same environment as production, and they don't understand why it's different. And how many of us? I think 3 of us. We are lucky because we had access to a really busy production environment, and we know how it looks like. But if you take an average developer, during their career, they will never actually touch environment that has more than 10 TPS and maybe gigabyte of data. They don't simply see it. This is why, if you trace the boring SQL blog, everything comes down to this is fine on your database, but it will eat your life on production because
Yes.
it won't work.
Yes, I compare it to bicycle. So it's hard to be DBA because you need to learn, but where to learn? If you don't have access to terabyte scale and heavy workloads, if the only practice you have is production, it's basically learning bicycle, how to ride bicycle on highway. It's like some people survived and they are called DBA now, right? Others, they say database is slow, it's dangerous, don't touch it. If you have an environment where you can safely make mistakes, I saw magic when people have access to terabyte scale clones and they start do really crazy stuff and realize it's wrong, but nobody affected. And this is how learning is actually works, it works so. So yeah, you're basically 100% resonating in my mind what you do.
And then take whatever you do, because I'm actually following your post on LinkedIn about self-driving Postgres.
Yeah.
Now you take people won't write SQL queries. They will not. Let's forget that it's a regression testing framework. They will not have this experience, and they will never hit issue that Postgres would be badly tuned.
Yeah.
That suddenly increases the gap. And sure, there will be AI which will help, but you still need a manual or human operator at one point, or somebody who will be able to diagnose where it went wrong.
Yeah, because real testing shifted to production. That's why, yeah. And we just need to shift it left again. Yeah. Yeah.
Exactly. So I think it's all about clarity and giving people. Sure, there will be. I think we will never have 10 times more DBAs. We will have probably 10 times less DBAs. But we need to make sure how the new people will actually learn those skills and how they will learn them predictably without that fear, without that, being scared. And who knows what will happen in 5 to 10 years.
Yeah, I agree. It's very resonates to what happened to code and containers. Containers is the way to have reproducible tests. It's standard, right? We just need the same for data. And copy on write is the key. But also methodologies should be adjusted, buffers. Yeah, so everything is so. And I agree, DBAs is like sysadmins. It's in the past. People need to learn Postgres who build stuff and know how to operate bigger databases coming from various angles. I have front-end engineers who already start understanding things. Or Supabase. Supabase is a great example. He attracted a lot of front-end engineers to learn SQL and so on, right? That's great, I think.
And that's the boring part, I have to make the joke because, for me, literally the direction where I'm going is those boring things are with us for 40 years. They will be with us for quite some time. And they just work. Those skills are reusable, no matter if you wrap them in LLM or not. Somebody needs to understand them.
Yeah. Yeah. So can you explain what your tool does? Assuming we understood this, that we need to focus on buffers during optimization and establish baselines focusing on buffers and cost. And we managed to achieve the same data using this feature in Postgres 18. What does your tool do and who should use it?
Okay, so the main goal of the tool is to find all your SQL queries and help you in some way to write a plan, because queries need parameters. It needs to have a way. So you need to write a fixtures or provide your dump database, anonymized database. That's your choice. I'm not actually forcing you in anything. You have to get it to predictable state. That's your snapshot. Then you run it on your queries, and based on your plan, each query can have 1 to n plans. That means what's the variation? So you can have LLM to generate you plans, using random values. You can have a fuzzy generated plans, and that means every single plan will execute that query once. What the tool does, it captures the expected. The original tool did it also. It captures the data. So what you have is, right now, it's a JSON with all the data that it produced. This is your baseline, and that's the contract for correctness of the queries. Then you have the functionality for baseline. So right now, the version 1.0 does explain only, but version 2.0 will have a full explain analyze, because that's what I need for buffers. And it records that data.
Yeah, what about other settings, modern settings like memory and serialize?
That is interesting because, again, this is the part of the 2.0 roadmap,
Okay.
because snapshot can't be consistent. You have to have a data. You have to have a now even configuration. So I'm not saving all the configuration, all the metadata about where it's running and how it's running, but I'm actually saving this as part of the snapshot. So if something changes, like if you change a configuration, what's the cost of sequential scan, it will warn you. You change something, and I will probably give you wrong result. So you still have to interpret the data. At one point, you arrive to a scenario where you have a Git commit, and you can distribute the snapshots for testing. So ideally, you can have a couple of versions of the snapshots. You can have a small snapshot, which will have 100 megabytes, 200 megabytes. You can have a mid-size 5 gigabyte snapshot, which you can use. And then you can have a large snapshot, 50 gigabytes or something. And then every time you run test, you will get your report, what actually has changed. And that change is based on the cost and buffers.
Yeah, that's great. And you capture also version, I think, right? And settings and
Yes.
And some like statistics and structure of table, which indexes we have and so on, right? We're basically in the same, like Matt at some point, it resonates a lot, but you come from development more, I come from production more. And in production, what also matters often, including buffers, for example, if you think about index-only scans, heap fetches matters a lot, right? Mm-hmm. And this is the state of production, which can be bad or good. And capturing from production the state, some statistics might make sense as well. Do you see somehow it could play or no? For example, when last time this table was vacuumed, how much dead tuples it has, or how much bloat accumulated, something like these things, or it's outside of your scope?
I spend so much time thinking about this topic, and if you would ask LLM, that would say, yes, that's your natural direction, but I actually proactively said no to this, because this is a different domain. Mm-hmm. You have to guarantee what's broken on the development side. You have to make sure that contract, which is also a performance or buffers, is same or better, and you track it, but you can't replace this in production, because in production you can have a latency, you can have a replica which run in different availability zone, you can have a network issues, you can have so many issues that can happen in production, and there are tools that I can't compete with, and I think that wouldn't be my goal, and because my angle is education, effectively, for me, it stops with CI.
Yeah, it again resonates 100%, because what you do, you say, let's split the system into pieces and study each piece separately. And when we understand each piece, behavior fully, then we can go and increase complexity. And that's why you shouldn't use pgbench to study plans, right? Because pgbench is the tool to test whole system. And also that's why you shouldn't bring too much from production. Study your system first, how it works, right? and then let's go to production, understanding our system and knowing what it's capable of already. Then we bring complexity. This is like the old, like one of the oldest scientific methods, René Descartes, right? It's like let's split two pieces, study each piece, and then composition to have whole understanding. Without this split, it's super hard, and you always have too many moving pieces, right? So I like this, but still I'm from production, so I care about the state of production. It's different. Yeah, cool.
I think we're talking about different things though, right? I really like that this is about regression testing. This is about not breaking things that like ourselves through development. This is not breaking correctness, whether that's a human changing a query or an LLM chatbot changing a query. So correctness is like primary importance, that makes sense. And ideally not affecting performance, but we can't measure production performance in test, in development. So all we can do is get a proxy for it. I don't think we can anticipate every single potential performance issue in development that could hit production.
Yeah, really produced really difficult problems. Yeah, with point-in-time recovery, sometimes you can reproduce really hard problems at macro level.
Reproduction is different from anticipation, though. Yeah. Anticipating, so to get it into your regression test, you'd have to anticipate every possible issue. And I think personally, I really like the direction of let's do one thing at a time. Let's tackle the common things. Let's
I'm
look
not
at
arguing with
costing.
the whole concept. I'm just saying that also is possible. It's just much heavier, much more expensive, time consuming. In development, we need to move fast, iterate a lot, and check dozens of ideas at the same time, like in parallel. Like, this is what we need, right? And this is perfect approach. So.
The last thing I wanted to say is I personally think that this hasn't been a topic that's been particularly of interest to people for many years. I've expected it to be, like I've thought it should be. I've worked at a company previously that made tools in this area that weren't very successful. And I was actually pleasantly surprised by how much positivity and interest there was on the Hacker News discussion and in your revamp of this tool. So for me, it's actually feels like people are ready for this topic for some reason. I don't know what
because
changed
people are
or
scared. What AI is writing there? Who knows, right?
Do you think that's what it is, Radim? From your perspective,
I think this goes to there's not one answer. Mm-hmm. First is going back one topic. How many % of incidents you deal are really production based? Like, no matter if it's human or LLM. I'll be just guessing. 90% of all incidents are change management that didn't go well, and something happened. So this is why the regression testing actually, when you, Michael, said you can't measure, but if you take a snapshot, something which is now working, you should actually do something that is measurable. You measure if you're improving on performance. So it's, sure, contract is important, but actually if you start with 0.0, you can technically say we on average go up and down in terms of performance. This is very easy to measure. And this one, for example, how many times you double guess when you upgrade from Postgres 17 to 18, what's the impact? You can suddenly put a number. And if you somehow put all your queries and do that number, you can put that number into a bucket. And the second one is no matter what you do, I was asking myself, why nobody thought about this one before. I actually don't understand why nobody did this, because it's predictable. The metrics were there, but nobody did it. And from my experience and the frustration I had was all the incidents were very easily avoidable because the metrics were not in the 10% margin. They were in 1,000%. Yeah. Every single incident started with 1,000% difference.
I have also important question about this tooling. So how do you capture queries to test? Because, for example, if we have ORM, it produces various queries. We can see PGSF statements, normalized queries in production, but for each query we might have multiple plans depending on parameters. So how to find those queries? I have my own methodology. It's actually described in some articles. We could collaborate maybe a little bit on it. But what's your approach?
this is the difficult part. I'm not going to lie.
Okay.
I come from Go background, and if you take ORMs are not that popular in Go, I would say. A framework like SQLX and things like this, one day encourage you to write SQL by hand or SQL queries by hand. And this is actually where it started. So effectively, my first commits were about supporting multiple queries in one file. So I have a different base. There are even frameworks like SQL C, I think, that generates code based on the queries or vice versa. But that would keep the target market very slow. So the obviously next step, and that's the support of the different frameworks. So I think in my article, I did a SQL Alchemy. That was one that actually allows you to save the queries. And this, if you remember, we talked about the plans. And plans are that variation of arguments.
Right.
So you have a artificially generated snapshot, which is fixed, and then you need to generate the plans. And plans variation, if you write one plan, your query testing is not going to be best one. So you need to generate, and this is actually where LLM can help you. Because suddenly you have a tool which can create the variation, create even hallucinate data. And you will be testing queries with I would actually be quite happy to have hallucinated parameters, because it will show you whether something is changing or not.
It's proactive approach, actually, because my approach is to take everything from production, because we deal with really large systems, and we need to understand when we, for example, perform major upgrade, there are no plan flips, so or plan flips are positive. But what you say, like, let's use LLM to generate parameters, which probably will happen next month, right? Like some edge cases we haven't met before. I like this a lot as well. Yeah.
Yeah, so you have to use what you are afraid of. So if we are afraid of randomized queries, then why not to use it? And effectively said, yeah, I need a variation of 1,000 plans.
Yes. Again, like the problem is, like, again, I have a slightly different opinion here, because I'm coming from production experience. I would say we can generate like thousands and thousands of various cases, maybe a million queries to test, but it will increase longevity and the price we pay for CI and testing, right? So we need probably to prioritize some queries. How to prioritize? We need to study production. No?
Exactly.
Okay.
That you need to understand your business requirements. You need to understand your outliers. You need to understand your smallest customers. You need to understand your biggest customers. You need to understand the patterns which are happening. So
that's also interesting comment, because I was thinking about like this tooling. Oh, by the way, parameters right now is just an idea. It's not implemented yet. A collection of.
No, that's already. The queries are already parameterized.
I mean, yeah, so I understand fixtures,
right
but if I have already a large 10 terabyte database with a complex workload and I want to start using your tool, will it help me to create a set of queries, example queries, which will be tested?
Queries we have to extract from somewhere.
Right.
So no, I would say answer is no. Because right now, I assume you have a queries or way how to capture the queries, either by having them in the SQL files or by being able to have a CI task that will generate those SQL files from your ORM.
Yeah, I would like to have additional call with you to discuss, because I have approach. Maybe we could connect the dots here and see if it can land, because this methodology probably works with your tool naturally, you know. How to inject this approach to existing big project. We deal mostly with projects already starting hitting walls. You know, they come to us for help. So I understand completely how to start from scratch. But when you have something already, there it can be difficult, right? Another thing I wanted to point out, what I hear, you say smaller, medium size, bigger. Sometimes we have only one database and that's it. Some systems like SAS, which is installed only once. But sometimes we develop software which has many installations, small, big ones. So it's interesting. I think the approach when you define some reference databases, this works better when we have multiple installations of various sizes. Is it what you think?
Yes, as I said, there's no universal answer how to generate. And many people actually wrote me about fixtures being completely wrong. But what I'm trying to get past is I don't care about the fixtures.
Right.
I care about the way how to generate a snapshot.
Right.
And if you have the same cardinality and same data, you can then measure correctness. So obviously the investment in a tool like RegreSQL is actually, it's a big one. You have to start using it and you will get dividends 12 months on. You might get some dividends as you go, but actually the true value will only go. So the developer experience and then whole life cycle, that's maybe a version 3.0 because, there needs to be much more support. So the tool itself is not important as much.
Yeah.
It's the whole experience in the
Methodology,
process because
yeah.
methodology, exactly.
So what I'm actually interesting, let me share, to be honest with you, and then what I have in my mind listening to you. For example, GitLab, they use our approach. Many engineers, that's great, and we have case study published. Everything is great, but listening to you, I realize actually we always cared about the biggest GitLab.com installation, which is huge, multiple database, huge, and we focused on solving that problem. We solved it not fully, but solved how to test queries there. It can be proved always. But now I'm thinking, actually GitLab has hundreds of thousands of other installations, and they have reference. And I think, well, we actually should care about that as well, right? So it's interesting because we could generate different sizes of database and covered by testing them as well. Yeah, so it's interesting because I was always thinking about the biggest one, because usually problems are usually there, right?
Exactly, you hear about the biggest ones. This is where, the production breaks, the incident starts, the query, which was fine. It sounds similar, but it's a very different problem. But you need to find some sort of boundary. Sometimes you can't solve all the issues, and maybe you need to find a different solution.
Right. Yeah, so it's interesting.
Just out of interest, Nik, what would you expect to break on a smaller instance? Is it that it's just a different shape? For example, on GitLab.com's main instance, maybe there's tons of one type of object, and in a different customer's installation, there's a different distribution, and therefore plans are different? Or is it
I can tell you. So what we think about, we have various kinds of testing, red data testing. It's ultimate final testing with basically production clones, which only few people can have access. But also, you cannot download this database due to size and also restrictions, PII and so on.
Yeah.
But what if you need to care about multiple installations? In this case, the direction DB-Lab is moving in is having full-fledged database branching Git-like, but also cloning between multiple setups, and we already run on MacBook. So I'm thinking, if you care about smaller databases as well, developers could basically download, reference a database and iterate much faster, because I hate how CI is organized right now. If AI is hallucinating, in production, if I hit it's absolutely nightmare. But hitting even in GitLab CI or GitHub Actions, hitting problems there, it's already too late for me. I want to iterate much faster. I want all the tests to be run before Git push, right? In this case, if we have DB-Lab of smaller size, you download it and you, don't hunt only for the biggest case, or medium size, small size.
Yeah.
I have a terabyte or so here. I can have good example database on my laptop and iterate much faster. And before push, I already have much better code,
Yeah, so catch more issues earlier and only catch
shift left what you can shift left.
Yeah, shift left.
Test.
Yeah, makes sense.
Yes.
Okay.
So it's saying let's test earlier. Ideally, developers should test. Usually they don't have time, but AI, I have no excuses to AI. AI should test everything. I pay for it, right? Tokens, not time, right? So yeah, and that's it. I think it's perfect time to think about all levels, and if you can shift left to your laptop, to your machine, you should do it, right? So future DB-Lab versions will be able to clone data to pass snapshots between two DB-Lab. You can have it on your machine and just extract, and then do something, extract back, and share with your colleagues, some tests and so on. Yeah. Anyway, I'm stealing agenda all the time because it's actually my topic. I'm so glad you came, actually.
Yeah. There's actually so many topics, and I think we can go for another hour because, it's the support. I think last night I pushed was the same one. You take the snapshot, you run it against migration, either a SQL file or command, so you can actually trigger a third-party system and then test the same just to test the migration, how it looks like. And you can start. There's so many angles on this topic alone.
Oh, yes.
I don't say I have answers for everything, but I just feel like I hit
let's
a
have
topic.
part 2 about testing of schema changes. Let's have part 2 just about it, because it's a big topic. This is where, exactly as you said, change management. This is where danger comes from usually in incidents, right? So let's just discuss it separately, because I think it's worth discussing.
Radim, was there anything on the regression testing side that you wish we had asked about or that you wanted to mention before we wrap up?
I think we have covered most of the things.
Where to start for people?
Where to start from people?
First steps.
First step, follow the project. I think that's the first good step. I will definitely make it public and do some, sessions around the version 2.0, because this is where the core developer experience will come. And I will actually need feedback on that. So I'm actually open to any feedback. You can email me at any point or open a GitHub issue. I would be actually grateful to see that. But I would say pick your 10 queries. Don't start with anything. Find a way how to pick 10 queries which you believe are maybe not small, I would say representative of something that's breaking. Try with them. Try to create the plans. Try the tool, how it works, what might be the flow, and try to live with it. And then have a rule that every single handwritten or LLM-written query needs to be covered. If you start with that, you will start seeing value in a couple of weeks, couple of months, because you will have that check mark, everything is fine. And then in future, hopefully all the features and the developer flow will support that you will get much more values and you will actually get your time back in terms of safer production.
Confidence level builds up. Yeah, I mean, small set of queries, but it's a good idea to understand which queries matter most based on some production behavior or something, right? And you have a website, boringSQL.com, so this is where you have blog and so on, and the project you're talking about is RegreSQL, right?
Exactly.
Yeah, great. Cool.
Right now, it's not featured. I'm preparing a section.
You have huge roadmap, I guess.
Right? You can't even imagine, and this is actually where I love it.
I can.
Well, I believe you can.
Yeah, that's great. And the project is written in Go, so that's great. Yeah, good. I think finishing words, right? Unless Michael has something.
No, I'll link to everything in the show notes if anybody needs anything that we've mentioned. And yeah, thanks so much for joining us, Radim. It's been great.
Yeah.
Thank you. It was very interesting, and I loved talking because it's an important topic.
Thank you for coming.
Okay, thank you, guys.
Thanks, both.